.NET Microservices Consulting, Architecture Patterns and Implementation Guide. Hey, welcome. In this video, we're breaking down .NET Microservices Consulting, Architecture Patterns and Implementation Guide. Let's get into it. Moving on to why .NET Microservices Consulting matters for enterprise teams. Enterprise teams rarely start a microservices project because a consultant recommended it. They start one because something broke, a competitor started shipping features in days instead of months, or a regulatory requirement exposed how fragile the current architecture is. .NET Microservices Consulting brings in a team that has navigated this work dozens of times, which matters most in two areas: drawing service boundaries correctly the first time, and choosing a migration path that doesn't bet the business on a big bang rewrite. A monolith is genuinely a liability when independent teams are stepping on each other's code, when business domains have wildly different scaling requirements, or when deployment cycles have slowed to the point where the organization can't respond to market changes. For a healthcare logistics company we worked with, a billing domain and a patient records domain had to deploy together despite completely different release cadences. Separating them cut the billing team's release cycle from every 6 weeks to weekly. .NET application modernization deferred for 2 or more years compounds the cost significantly. Engineers who understand the legacy codebase retire or leave. Recruiting to a .NET Framework 4.x codebase gets harder every year. Security patches require testing against an increasingly fragile system. The hidden cost isn't the migration itself, it's the features never built because the architecture couldn't support them, and the incidents caused by changes in one domain cascading into another. Our .NET application modernization, a 5-phase roadmap from legacy to cloud-native, covers the phased approach in detail. Next up, core architecture patterns every .NET microservices project needs. These patterns appear in every production .NET microservices system we've built as part of our ASP.NET Development Services work. They aren't optional extras, they're the structural decisions that separate systems that are easy to operate from ones that generate new operational problems as fast as they solve technical ones. When services need to communicate without tight coupling, event-driven architecture is the right choice. In .NET, this means Azure Service Bus for enterprise workloads. A service publishes an event when something meaningful happens, and downstream services react without the publisher knowing who is listening. The discipline is in designing event contracts. A schema that is too narrow requires constant updates. One that is too wide leaks domain knowledge across service boundaries. For enterprise application development projects, we use versioned event contracts and treat schema changes as breaking changes. Command query responsibility segregation separates read and write models, which matters when those workloads have different scaling requirements. Event sourcing stores state as a sequence of events rather than a current snapshot, giving you a complete audit trail at no additional infrastructure cost. This is particularly valuable in banking and healthcare where audit requirements are strict. Mediator is the standard .NET library for CQRS implementation, paired with Entity Framework Core for the write side and a read-optimized projection layer for queries. Now, how to migrate from .NET Framework to .NET 8 or 9? .NET 9 migration is structured work, not a simple upgrade wizard. It requires assessing compatibility, updating dependencies, and in many cases refactoring code that relied on APIs that no longer exist in modern .NET. Teams that treat it as a weekend project end up with systems that partially run on the new runtime while key dependencies still target the old one. Before writing a line of migration code, you need to understand what you're working with. Microsoft's .NET Upgrade Assistant analyzes your solution and flags compatibility issues. The key things to assess are third-party library compatibility, use of Windows-specific APIs, and any web forms or WCF usage. Web forms has no direct equivalent in modern .NET. WCF services typically need to migrate to gRPC or REST APIs. These decisions shape the timeline more than anything else. For any .NET 9 migration, this sequence reduces risk significantly. Let's talk about now the Strangler Fig pattern, modernizing without the big rewrite. Legacy .NET Framework modernization uses the Strangler Fig pattern to incrementally replace components without a full rewrite. This is the approach we recommend for most enterprise modernization projects. The alternative, a full rewrite, fails at a rate that should give any engineering leader pause. The strangler fig pattern places a facade layer in front of the legacy system. New features are built as separate services behind that facade. Over time, functionality migrates from the legacy system to new services, and the facade routes increasing traffic to the new stack. The legacy system is retired gradually as each component is replaced, not in a single high-stakes cutover. In .NET, the facade is typically an ASP.NET Core reverse proxy using YARP. Martin Fowler's description of the strangler fig application pattern is the authoritative reference, and it maps directly to the way we structure .NET legacy app modernization engagements. This question comes up in almost every legacy app modernization conversation. The honest answer: if the business logic is sound but the infrastructure is outdated, modernize incrementally. If the code is tangled to the point where engineers can't reason about it without executing it and watching what happens, a targeted rewrite of specific bounded contexts makes more sense. For teams in regulated industries, modernization is almost always preferable because it preserves audit trails and compliance documentation continuity. Now, next up, Blazor Development Services, choosing the right frontend. Blazor Server renders UI on the server with SignalR. Blazor WASM runs C# directly in the browser via WebAssembly. Both are production ready in .NET 8 and 9. Choosing between them requires understanding your latency tolerance, offline requirements, and team composition. Blazor Server keeps all application logic on the server. The browser receives HTML updates pushed over a SignalR connection, which means faster initial load times and direct server resource access. The trade-off: every user interaction requires a server round trip, making it unsuitable for high-latency environments or offline scenarios. Blazor WASM ships the .NET runtime to the browser and runs C# client-side. This removes the SignalR dependency and enables offline use, but the initial payload is larger. For enterprise application development in controlled network environments such as internal operations dashboards, Blazor Server is the better choice. For customer-facing applications with geographically distributed users, evaluate the payload size impact carefully. Blazor's core advantage for .NET teams is full-stack C# development without language context switching. A team writing C# all day doesn't have to switch to TypeScript to build the front-end, which enables genuine code sharing between client and server, shared validation logic, shared DTOs, shared business rules. Blazor Development Services make the most sense when the team is already invested in .NET and the application is primarily internal or data-intensive. React is the better choice when you need a broader developer talent market or a richer third-party UI component ecosystem. Our detailed comparison at Blazor versus React for enterprise apps, when each one wins, covers this at the level of specific use cases. Now, moving on to how API development services fit into a microservices strategy. API development services are the connective tissue of any microservices architecture. In .NET, this means designing APIs that are consistent, versioned, observable, and aligned with how services actually communicate, not just functional at launch. REST is the right choice for external-facing APIs, familiar, toolable, and works over standard HTTP infrastructure without special client libraries. gRPC is the right choice for internal service-to-service communication where you need low latency and strong type contracts. Many well-structured .NET architectures use REST at the edge and gRPC internally. URL versioning is the most explicit versioning approach and the one we recommend for public APIs where clients are outside your organization. An API gateway handles cross-cutting concerns, authentication, rate limiting, routing, and logging. In the Azure ecosystem, Azure API Management is the managed option. YARP, available at microsoft.github.io/reverse-proxy, is the .NET native open-source alternative for teams that need more control. The gateway should stay thin. When gateways accumulate business rules and conditional routing logic, the result is a distributed monolith where the gateway becomes a deployment bottleneck. For teams deploying on Azure, the CI/CD decisions that support modern API development services workflows are covered in our post on Azure DevOps versus GitHub Actions. Which CI/CD pipeline fits your team? Moving on to what to expect from a .NET Microservices consulting engagement. A good .NET Microservices consulting engagement has defined phases, clear deliverables, and exit criteria at each stage. It is not an open-ended retainer where activity is visible but outcomes are vague. When selecting a custom software development company for microservices work, the questions that matter are concrete. For teams in regulated industries, verify that compliance requirements are embedded in the delivery process, not added after launch. Our post on banking software development, "What you need to know before starting," is a useful reference for what this looks like in practice. Now, next up, conclusion. .NET Microservices Consulting pays off when it's done with structure, service boundaries drawn from domain analysis, a migration strategy built on incremental approaches like the Strangler Fig pattern, and a consulting partner with a track record on .NET application modernization and ASP.NET development services projects. The patterns in this guide hold up in production across healthcare, logistics, banking, and SaaS. If your team is running a .NET framework application and deployment friction has become a strategic problem, the right time to act is before the next major release cycle. Connect with our team to start with a blueprint sprint and get a clear picture of what modernization looks like for your specific system.